We are group number 7, and we will be going over the conservation of mass. Well, what is the conservation of mass? The conservation of mass states that in an isolated system, mass cannot be created nor destroyed. To give you an example, let's take a block and put it through some change. Let's say we take that block and we were to just cut it in half down the middle. What we'd end up with is something like this, and this would be our change, just a simple physical change. So we have some initial mass here, or mass 1, and we have some final mass, or mass 2. They look different, but based on the conservation of mass, they must be the same mass. And that is what our equation is. Mass 1 equals mass 2, or in this case, our initial mass is equal to our final mass.
The objective of the first experiment is to demonstrate the conservation of mass with a combustion reaction between baking soda and vinegar inside an airtight resealable bag. We know that mass is conserved in a chemical reaction, so the mass of the reactants should equal the mass of the products. Specifically, the chemical reaction equation is sodium bicarbonate plus acetic acid equals sodium acetate plus water plus carbon dioxide. Because the products include water and carbon dioxide, this is a combustion reaction. It was decided that inside an 11.5 gram resealable plastic bag, we will combine 45 grams of baking soda with 150 grams of 5% acetic acid vinegar. For this experiment, the total mass of the reactants and the resealable bag is 206.6 grams. So logically, the mass of the products and the bag should also be close to 206.6 grams.
First, we poured the vinegar into the plastic bag. We made sure to partially seal the bag before adding the baking soda so that we don't lose any carbon dioxide. We then poured the baking soda in the bag and sealed the bag immediately in order to prevent any carbon dioxide from escaping. As you can see, we can tell a chemical reaction is occurring by the changing in color and the creation of CO2 gas within the bag.
Indeed, the total final mass of 204.1 grams is nearly the same as the total initial mass of 206.5 grams, indicating that mass was conserved. The final mass is slightly less, probably due to carbon dioxide escaping when closing the bag, or small amounts of reactants being lost during the transfer to the bag.
For the second experiment, we performed the desalinization of water by introducing salt water to heat so that we can separate the solid salt from the liquid water. The initial mass of the salt water was recorded to be 25.5 grams. Here is our initial setup for this experiment. Water is being evaporated and is condensed in the long glass tube, while the solid salt is left behind. We then recorded the mass of the condensed water and the solid salts left behind and summed them up to get our final mass. As you can see, our final mass was 24.66 grams and our initial mass was 25.5. We lost 0.84 grams due to vapor escaping our setup.
Reverse osmosis desalination is one application of the conservation of mass to a real-life process, and it can help fix the lack of clean water in the world. Reverse osmosis is a process performed on seawater that results in fresh water and brine. The mass of the seawater should be roughly the same as the mass of the brine and fresh water after. As seen in the figure, none of the byproducts are wasted as the brine can be recycled to regain some energy.
In conclusion, the initial mass of our reactants was equal to the mass of our products in both the baking soda vinegar reaction and the desalinization reaction. Therefore, we have successfully proved the principle of the conservation of mass.